Hola, kids. This is Chapter 7, Lesson 3. And before I get started, the topic of today's lesson is solve and write subtraction equations. And I actually forgot this part on the last lesson. Lesson 2 should have been solve and write addition equations. So that part should have been on the last lesson's title. Before we start, I want to give you a couple of reminders, and I'm going to do these with little drawings up at the top of the page. So I just want to remind you that a scale is like a balanced equation. An equation is like a balanced scale. You've got something equal to something else. That's what an equation is. An expression equal to another expression. But we talked about thinking about how that's a scale that's totally balanced. And we also talked about inverse operations. These are operations that undo each other, is what we say in math. And we use these in equations. So to undo addition is subtraction. These are inverse operations. To undo subtraction, addition. To undo multiplying, we divide. And to undo divide, we multiply. So just a couple reminders before we get started. All right. Just like last lesson, there was a subtraction property of equality, there is an addition property of equality. And you're going to realize, hey, this thing's real similar. The addition property of equality says, or means, it means you can add the same amount to both sides, and the scale will stay balanced, or we would say that the equation remains equal. If we have a scale that's balanced, we could add 5 pounds onto this side, and we could add 5 pounds onto that side, and it's going to stay. It's not going to go up or down. It's going to stay balanced. This side is going to equal this side, as long as we add the same thing to both sides. That's the addition property of equality. Okay, next we're going to talk about writing an equation from a situation, kind of from a story problem. Okay, so here is the situation that we're going to build an equation from. Alex has a bike and he has rollerblades. Alex's rollerblades His rollerblades cost $70.25 less than his bike. His rollerblades, I'll abbreviate RB for rollerblades. His rollerblades cost $43.50. So again, his rollerblades cost $70.25 less than his bike. Bike would cost more than rollerblades. That kind of makes sense to me. So how can we take this story, this situation, and build an equation from it? So our steps, what we're going to do, first we're going to try and get a statement in words from this, a single statement. This takes, for most kids, a lot of practice. How do you take a story problem and translate it into a math statement and then build an equation from it? But stick with it. Just keep practicing and trying. You got to just try something to get going. So take a look at this. $70.25 less than. Well, less than to me means you're subtracting. You're subtracting $70.25, but in this situation, what are you taking $70.25 away from? Well, it's his bike. The cost of the bike. Cost of the bike is, or minus, I could say, minus or less than, minus $70.25 is the cost of the rollerblades. So that is the first step. Try to come up with a sentence that comes from the situation. The cost of the bike, cost of Alex's bike, minus $70.25 is $43.50. I can get this statement from this story. So next, we are going to define a variable. Another way to think about the variable is what don't we know? Well, we know the cost of the rollerblades. What we don't know is the cost of the bike. So I'm going to assign the variable b, and I'm going to say that b is cost of bike. Again, I could have picked any variable. I could have said c for cost of the bike, but because bike starts with a b, I just am choosing b. The next thing, now this one's optional, but for a lot of kids it helps. Build a diagram or a model. Drawing is always a good idea in math. Way more kids got to draw things. When you're stuck, see if you can draw it out. So in this situation, we've got something that we don't know, cost of this bike. So I'm going to make a bar. I've used bar models a lot. And this whole bar represents the cost of the bike. I don't know what this is. It's the cost of the bike. Now, what we do know is if we take away $70.25 from this bike, we will be left with $43.50. Here's the cost of the whole bike. If we take away $70.25, we are going to be left with $43.50, the cost of the rollerblades. Last but not least, an equation. So here is our full situation over here. Here is our kind of summary sentence in words. The cost of the bike minus $70.25 is $43.50. We're going to translate this into an actual equation. So this has numbers, but it also has some words. Now we're going to get to straight math down here. Cost of the bike is B. Cost of the bike minus, well in math, that's subtract, $70.25 translates into equals. So now there is an equation that we have built from this situation. And to do that, we went through the steps. Come up with a statement in words that summarizes the whole thing. Assign a variable. make a diagram if that helps your thinking, and come up with an equation that translates from the word that you came up with. Cost of the bike, take away $70.25, is the cost of the rollerblades, which is $43.50. So now we have an equation, and now we're going to talk about solving it. So I'm going to rewrite the equation over here. Cost of the bike, take away $70.25 equals $43.50. Now how do we solve that? B, subtract $70.25 equals $43.50. Now, just like we did with solving addition equations, we start by looking at the side with the variable. B, subtract $70.25. How do we undo subtracting $70.25? Well, the inverse operation of subtract is add. So what we are going to do is we are going to add $70.25. Now, subtract $70.25 and add $70.25 actually cancels each other out. It becomes 0. Take away $70.25, add $70.25. Well, if you put those two things together, you'd have 0, nothing. But because I have added $70.25 to this side, I have to add it to that side because of that equal sign that is super powerful. If I didn't add $70.25 to this side, my scale would do that. It'd be out of balance. So I have to add this to both sides. That right there is the addition, coming back to this, addition property of equality, right here. So you have to show in your work that that's what you are doing. You are adding $70.25 to both sides. Well, like I said before, this is going to cancel each other out, become 0. So on this side, we are left with B. And on this side, remember when you're adding or subtracting decimals, they've got to be lined up. Well, they are lined up. Okay, they are lined up. It comes straight down in our answer, and then we just add. 5 and 0 is 5. 5 and 2 is 7. 3 and 4 and 7 is 11. So the answer is cost of the bike is $113.75. So this is the solve up here. This is the write an equation part right here. So I'm going to put a big highlighted box around this. This is what your work should look like today. Even if it's a simple equation that you can solve in your head, and there are definitely, that's going to happen, I want you to follow the process, show that you're adding something to both sides if it's a subtraction equation, and this is what your work should look like. Okay, follow the process. Remember, you're going to run into stuff that you can't do in your head. Got to be able to fall back on a process. Okay, the last, so this is the solve. This is the write. Up here was our process to write equations. Here we're solving it. And the very last thing we're going to do is check. We're going to check our solution. How do you check your solution? You put it back into the original equation, what you think the answer is. So the original equation was B subtract 70.25 equals 43.50. I take my answer and I substitute it in for B. 113.75 subtract 70.25, and hopefully that equals 4350. Check that on my calculator, and yes, it works. That is the check step. Okay, so just highlight that. This is the check step. You plug what you think your answer is back into the original equation and hope that it works. If I got an answer and I plugged it into the original equation and this wasn't true, that would tell me made a math mistake somewhere, either my equation's off or made a math mistake, subtracted wrong, something's not right. Really important you get in the habit of doing that check step. Okay, well, that does it for lesson 3. Last thing to show you is hidden treasure for chapter 7, lesson 3. There it is. Figure out that puzzle, and you could be the lucky winner. That does it. I'll see you soon for chapter 7, lesson 4.